So what I have to do here is in e raised to e of x raised to n is just you just have to multiply this x raised to n, because in e of x also you just add, like f of x is your probability and x is your just this stuff. In e also e of x also you just add this just. So when e raised to x, obviously you just change the x only, like x raised to n, because even in discrete one you do just p of xi square, right? You don't change the pi, only xi square changes like that. What we have to do here now. So that much x to x raised to you have to put. Now we have variance here, so that is x raised to 2. So we f of x is our this and k was 1. We knew that, so we just have to substitute this, and 1 changes nothing, so it's just this function x squared. So we have to just pull up at this x squared e raised to minus 6 x squared squared. Obviously, you must know that a raised to m plus an is equal to a like if you have base same, like if you have bases or variable same and raised to different, or even raised to same, you just add them, because this is some multiple, this is some multiple. If you multiply them, increment in multiple, like adding of multiple. Okay, so that's why this formula works, right? Just add them, have fun. Equation minus if okay. But I put in wait a second in this mean also I have to put infinity constraints, limits. I forgot about that, but we can do that later. And this is x raised to 4 e raised to. So we have what I did here is, so I just added this, which is x plus 2, which is 4 here, okay? And e raised to minus 6. Now as you know, these both are multiplied and x terms, and both have to take integration. For that we have formula, as you must know, u v is equal u integration v minus so what is it? It doesn't integrate, v always integrates. That's how it goes. Now integration whole bracket du by dv. This only differentiates. First it doesn't differentiate, then differentiates. Then this only integrates. So it is double integration now. So this is going crazy. So now we have to do the C. So first is so we take Liet rule here. So Liet says log first. U priority this is, okay. This is theta inverse. This is x terms. This is theta terms. Cos theta sin theta. This is e. E is the last like u priority, so it is always almost v. I told you in previous lecture that e doesn't change and we need u to change so that it reduces to 0 and our integration chain breaks, okay. So and that's all you understand, right? Okay, so our x raised to 4 is the u here, so we have to apply this u as it is x raised to 4 integration of v, and we don't need raising power and e raised to x in v. Mostly integration is there, most various functions raise power here, but since e raised to x doesn't change, so this power won't increase and it is beneficial for us. We in integration don't need increasing power, it will be more complex. We need to reduce power, and reducing power only can be done by derivative part, because it is multiplied to integrated part, so this can cancel this too. So that's why it's helpful to choose your u wisely, that's what like best thing you can do. And u integration of v minus whole integration du by dv, okay? du by dv. U is x raised to 4 by dx. Not dv, bro, dx, bro. What am I doing here? Now integration of v, v is this, e raised to minus 6. Like here, this one, second one. So now what we do here is, x raised to 4. Integration of, by the way, integration of e raised to x is e raised to x, right? And integration of f of a, where a is a function of f of x. Then, integration of f of a is integration of f of a divided by, because in derivative multiply derivatives, here we divide inside derivative, d by dx of a. So this is our inner outer function, this is inner function, and here in e raised to minus 6, this is a